In the limestone valleys of southern Europe, beneath layers of sediment and ancient ice, rest the bones of a people who were once our closest relatives. For more than 150 years, they have lived in the shadow of our own narrative, portrayed at times as primitive hunters, at others as tragic remnants of a lost world. But now, ancient DNA is beginning to speak, and what it's revealing could reshape everything we believed about where Neanderthals truly originated. For decades, their beginnings remained a mystery. Their remains stretch from the caves of Spain to the vast plains of Siberia, dating back hundreds of thousands of years. Yet their genetic code, the blueprint within their cells, points to an even older journey, reaching back to a time before Europe had ever known their presence. A recent study, led by an international team of geneticists and paleoanthropologists, examined DNA from Neanderthal fossils across multiple regions, from the well-known Vindia Cave in Croatia to the remote Altai Mountains of southern Siberia. The findings linked together climate change, migration patterns, and encounters with other ancient human groups. Neanderthals were not an isolated branch. Around 600,000 years ago, they diverged from a common ancestor shared with modern humans, likely Homo heidelbergensis, somewhere in Africa or Eurasia. But their precise place of origin remained unclear, with DNA offering few answers. Until now. The researchers analyzed both nuclear and mitochondrial DNA, the latter passed down maternally, extracted from bones and teeth preserved in permafrost-like conditions. These genetic sequences were compared with hundreds of ancient and modern genomes worldwide, and what they uncovered was remarkable. The earliest Neanderthals carried genetic traces of an even older lineage, one that appears to have come from the East, possibly Central or East Asia, before moving westward into Ice Age Europe. One of the most compelling discoveries came from the Altai Neanderthal, a female who lived over 120,000 years ago. Her DNA revealed evidence of interbreeding with another mysterious human group, the Denisovans, deep in prehistory. This suggests that the Neanderthal story was not a straight path from origin to extinction, but a braided network of interactions, exchanges, and migrations. Genetic data also shows that not all Neanderthals were alike. Early Western populations, such as those from Spain's Cima de los Huesos site, dating back more than 430,000 years, displayed genetic differences from their Eastern counterparts. This implies that multiple waves of Neanderthals entered Europe, replacing, mixing, and sometimes coexisting with one another. But if their roots trace back further east, what brought them there? Climate likely played a decisive role. Ice Age Europe was marked by harsh winters and constantly shifting environments. Glacial cycles forced populations southward into refuges, then drew them north again during warmer interglacial periods. These movements may have connected Neanderthals with distant populations, including early ancestors of modern humans, far earlier than once believed. The DNA revealed something else as well, a small but significant contribution from an even older hominin, possibly Homo erectus, pointing to deep evolutionary roots in Asia before their expansion westward. This unexpected connection suggests that the true birthplace of Neanderthals was not a single location, but a vast, interconnected range spanning thousands of miles. What is becoming increasingly clear is that Neanderthals were far from the slow, isolated beings we once imagined. They were explorers, innovators, and survivors of immense journeys. The next clue in their origin story comes from a place that has puzzled archaeologists for decades, Mesmaïskaya Cave in the Caucasus Mountains, a rugged passageway between Europe and Asia. Here, researchers discovered the remains of a Neanderthal child, her bones still echoing a life that ended over 40,000 years ago. Her DNA told a different story than that of Western European Neanderthals. She carried genetic links to populations much farther east, reflecting ancestry similar to that seen in the Altai Neanderthal. This strengthens the idea that the Caucasus served not as a barrier, but as a bridge, connecting Ice Age Europe with the vast expanses of Asia. The timeline revealed by these genomes is staggering. Between 100,000 and 60,000 years ago, Neanderthals expanded and re-expanded into various regions multiple times. Each migration left subtle marks in their DNA, like annotations in a book we never expected to read. And with each movement, they may have encountered other human groups, including our own ancestors. This matters because the story of Neanderthals is also the story of us. Today, every non-African human carries, on average, about 1 to 2% Neanderthal DNA. This inheritance comes from ancient interbreeding events, some likely in the Middle East, others possibly farther east, as modern humans began migrating out of Africa around 60,000 years ago. But new genetic evidence pushes some of these interactions much further back. In fact, certain Neanderthal lineages appear to have received genetic input from early modern human relatives more than 200,000 years ago, long before the major migration of our species. This points to repeated cycles of contact, separation, and reconnection over hundreds of thousands of years. So why did Neanderthals disappear around 40,000 years ago, despite their adaptability? DNA offers part of the answer. Toward the end, their populations became small and isolated. This led to inbreeding, reducing genetic diversity and increasing vulnerability to disease and environmental pressures. At the same time, modern humans, equipped with broader social networks, more advanced exchange systems, and possibly more adaptable technologies, began spreading rapidly into their territories. Yet, the genetic record reveals one undeniable truth. Neanderthals did not simply vanish. They left a legacy embedded within us. Their genes continue to influence our immune systems, metabolism, and even how our skin reacts to sunlight. In a way, they never truly disappeared. As ancient DNA technology advances, scientists are searching for Neanderthal traces in unexpected places. In cave sediments without visible bones, in ancient tools carrying microscopic residues, even in the hardened plaque of fossilized teeth. Each discovery sharpens the image of a species whose origins were far more dynamic than the static museum displays suggest. The true origin of Neanderthals is not a single point on a map. It is a web of migrations, interactions, and adaptations spanning continents. It is the story of a people shaped by ice, by encounters with others, and by memories of lands separated by thousands of miles. And as the evidence continues to grow, one truth becomes harder to ignore. To understand them is to understand ourselves. Because within every strand of our DNA are echoes of their struggles, their resilience, and their endurance. They crossed landscapes that would break most of us, hunted in cold so intense it could kill within minutes. And still, they adapted. The wind that tore across their shelters, the firelight flickering against stone walls, the shared meals, the stories and songs we will never hear, all of it left a mark on who we are today. And when we follow their story, we are not just uncovering the past. We are rediscovering the missing chapters of our own. Thank you for watching. If you enjoy historical mysteries explained through science, don't forget to like and subscribe. See you in the next discovery. Goodbye.